Let's start with Pulley and Incline now. So we have this as a situational diagram. We have a horizontal surface where at the corner of this surface there is a pulley, ideal pulley, we should say. And then object 1 with mass 15 kilogram is tied at the end of one string, and the other one is dragged into the surface that is a frictionless surface with mass 20 kilograms. So what we are doing here is we are finding what is the acceleration, what is the tension, what is force normal that object is experiencing. And on this case, since object 1 is not on a surface, then the only force normal that exists is for object 2. So we can easily say what is force normal of object 2. Okay, so as we have done on every situation, the very first thing that we do is we define the direction of the motion. And when we dealt with this as well, when we are dealing with the frictionless surface, doesn't really matter which direction you pick. You can even pick that the object is going up, but now we will consider that the direction of the motion is clockwise. Direction of motion. So very first thing that we do after we define the direction of the motion, we build the free body diagram for object 1 and object 2. So the very first object has a dot, that is the object of our interest, and starting with the universal force of gravity, this will be 15, that is the mass of the object, times 9.81. So will be 147.15 newtons. And then we have a tension here. And what we are saying is that the object is moving down. So based on our direction, we are saying that the object is moving down. For the second object, the free body diagram will be the dot that represents the object of our interest, that in our case is object 2. And we have force of gravity that is going down. So force of gravity of object 2. And it is 20 kilograms times 9.81. And it is 196.2 newtons. And then we have a tension that in our case is going horizontal. Notice here that we don't change the way that we draw the free body diagram or the tension on the free body diagram. We say starts from the object, goes along the string, starts from the object, and the string on object 2 is horizontal. So it is something like this. Since the object is on a surface, then the third force that the object is experiencing is a force normal of object 2. And since we do not have a friction or a force applied, then those are the only forces that object 2 is experiencing. Is this clear? And for object 2, it is moving on this direction because we are assigning that object 2 is going east, let's say, and object 1 is going down. Notice here again what we emphasized at the pulleys, that the tensions are the same. I should draw this a bit more equal to this first one. The tensions are the same in magnitude, but different directions. And we do not mention what is the direction of the tension when we are stating it at the end of the problem, when we are solving it, because we know, drawing the free body diagram, we know what is the direction of the tension. Okay, after this, what we do is we build the table of components. So we go the horizontal for object 1 and the vertical, and then we have force of gravity 1, tension 1, not tension 1, and force net. In the horizontal, 0, 0, 0. On the vertical, what do we have? Force of gravity is negative because it is going down to the opposite of the positive vertical axis, negative 147.15. Tension is positive T. And acceleration, notice what we said, the object 1 is going down, so will be negative 15 times acceleration. Questions on this step? Is it clear to everyone? For object 2, we will again build the table of components. So object 2, horizontal, vertical, we have force of gravity 2, we have tension, we have the force normal, and we have force net. After we are done with all the forces, then we write force net. So on the horizontal, for the force of gravity is 0. For the vertical is negative 196.2. Tension in the horizontal is positive T. In the vertical is 0. Notice here that we are now tension becomes or has a horizontal component, but we don't have the power to change it. We will write what it is there. We just modify things based on the correct mathematical steps and logic. We don't flip things just because this is what we have seen before. The horizontal is equal to 0, and the vertical is equal to positive force normal. The object 2 is moving in the horizontal direction, and it is going east in the positive horizontal component. So this will be positive 20 times A. And in the vertical is not changing, okay, because it is staying always on the surface. Is this clear? And as we have done all the time, from the table of components, we withdraw the equations and then we solve for the unknown. On this case, what we have is from the first object, we have negative 147.15 plus T is equal to negative 15 times acceleration. From the second object, what do we have is T is equal to positive 20 times acceleration. And from the vertical, what do we have is negative 196.2 plus force normal 2 is equal to 0. And this is doable. Why is it doable? Because we have as many equations as variables we do have here. So we have 3 equations, 1, 2, and 3, and we have 3 variables, A, T, and F normal. We'll start with the easiest one. How do you solve it is totally up to you. It's exactly totally up to you. I will solve it using math, not calculator. So from equation 3, force normal will be 196.2 newtons. And now This is what you will try on the another example. If we have a force of friction, then you know force normal, which means that you will know force of friction. So now we will use those 1 and 2 equation. So we'll have T is plus 15 times A is equal to 147.15. I'm just rearranging it. And T minus 20 times A is equal to 0. So I'm just rearranging equation 1 and equation 2 and subtracting the 2 together so that T is canceled, and then we will have 35A is equal to 147.15. Divide both sides by 35, and then A will be equals to whatever the calculator is telling us. Divide by 35 is A is equal to 4.20 meters per second squared. Is this clear? The last step will be to find T. So T, I will use equation 2 as the easiest one. 20 times A, which means is 20 times 4.20. So 4.20 times 20 is equal to 84 newtons. So tension will be equals to 84 newtons. This is it for this question. So this being the situational diagram, the free body diagram of both objects, starting with object 1, will be something like this. We have force of gravity 1, which is 15 times 9.81, and we have tension that is starting from the object going along the string. And for object 2, it's a bit more complicated because we will have a force of gravity of object 2, which is always starting from the object going toward the center of the Earth, and in magnitude will be 20 times 9.81. And here we have the tension that is starting from the object going along the string. So tension is this way. And the other force that the object is experiencing, since it is in the surface, is force normal. So this will be force normal. However, since we have a friction now, then we will have a force of friction. But if we are saying that the object is moving in this direction, kind of clockwise, then object 1 is experiencing a motion that is going down, and object 2 is experiencing a motion that is going to the right. Therefore, force of friction will be against the motion, in the opposite direction with the motion. Then force of friction will be something like this. Now, we'll start with a table of components for object 1. So object 1, horizontal, vertical, force of gravity 1, tension, and force net. I'm not doing it quite nicely, but you get the gist of it. So now 15 times 9.81 is negative 147.15. Tension is positive T. Since the object is moving down, meaning that is moving in the opposite direction of the positive Y, so will be force net will be mass negative mass of object 1 times acceleration. Let's build a table of component for the second object. So here we have the second object, horizontal and vertical. And here we have more forces. We have force of gravity. We have tension. We have force normal, force of friction, and we end up with force net. So in the horizontal component, force of gravity is equal to 0. In the vertical is negative because it's going down, 196.2. Tension in the horizontal is positive tension. In the vertical is 0. Force normal in the horizontal is 0. In the vertical is positive force normal. Force of friction in the horizontal is negative force of friction. And on the vertical is 0. And what do we have here? The object is moving in the horizontal direction, positive direction, with a positive horizontal. So will be positive 20 times acceleration. And it is not moving in the reference to the vertical axis. So force net will be equals to 0. From this table, we bring the equations, and the equations are as follow. From the horizontal of object 1, we cannot get anything because it is 0, 0, 0. But from the vertical, what we can get is a negative 147.15 plus t is equal to negative 15 times acceleration, and this is equation 1. From the horizontal of object 2, what we can get is tension minus force of friction of object 2 is equal to positive 20 times acceleration, and this will be equation 2. And from the vertical of the object 2, what we can get is negative 196.2 plus force normal of object 2 is equal to 0, and this is equation 3. Here we have 3 equations with 3 variables, force normal, actually 4 variables, force normal, acceleration, tension, and force of friction. But force normal and force of friction are kind of related to each other. From equation 3, we find that force normal is equal to 196.2 newtons. Knowing the fact that force of friction is equal to coefficient of the friction times force normal, we will have coefficient of the friction, I think it was 0.15. 0.15 times force normal, that is 196.2. So in your calculator, 0.15 times 196.2 will be 29.43 newtons. So then force of friction is 29.43 newtons. Are we good? Excellent. Now we take this value of force of friction and we substitute it in equation 2, and then we will have negative 147.15 plus t is equal to negative 15 times acceleration, and t minus 29.43 is equal to positive 20 times acceleration. How you can solve this? You can make an equivalent system saying t plus 15 times acceleration is equal to 147.15. Oh, and for the second one, t minus 20 times acceleration is equal to 29.43. And you can solve it any way you want. You can solve it using even the calculator, the matrix function that I told you the other day, or since t is with the same coefficient on both equations, you can subtract the two, and this will be 35 times a is equal to 147.15 minus 29.43, 117.72, and then divide both sides by 35. Acceleration will be divided by 35, 3.36 meters per second squared. So here you have the other quantity that you were looking for, and then you take this value and substitute it on any equation. Any of them should give you the same answer, so I will substitute it on this since it seems that is the easiest one. T minus 29.43 is equal to positive 20 times 3.36. So 20 times 3.36 plus 29.43 is tension is equal to 96.63 newtons. And this is how you solve those type of questions. Work. So after we build the free body diagram, as you see it here, for the first object, it is easy. It is force of gravity going down and force tension is along the string. And for the second one, it's a bit more complicated because we have force of gravity that is going down, force normal perpendicular to the surface. And it is a tilted one, it's an incline, so therefore it's perpendicular to the surface, not vertically up. And then since it is an incline, what we do is we rotate the horizontal and vertical axis to match the horizontal, the direction of the motion, and the vertical perpendicular to the surface. And then we have the tension that is along the string. Again, the same rule as for every time that we draw the tension, starting from the object going along the string. So now we will start with the table of components for the first object. We'll have horizontal and vertical, and we have force of gravity, tension, and then since those are the only two forces that the object is experiencing, then we will say force net. For the horizontal, as we have been saying, it's 0, 0, 0. And for the vertical will be 15, that is the mass, times 9.81 is 100, negative 147.15. The tension is positive tension. Now the object is moving up, which means that force net will be positive 15 times acceleration. The same table of components we will construct for the second object, but now in this case will be a bit more complicated because we will have the horizontal rotated and the vertical rotated. And here we will have the force of gravity and force normal of object 2. We'll have tension. And if we have a force of friction here, force of friction will be the same direction as the tension because it is in the opposite of the, force of gravity will be 490.5. So it is 490.5. And the horizontal component of force of gravity will be positive, is this vector here, and will be 490.5 times sine 30, which is positive 245.25. And the vertical, which is this vector here, will be related to cosine. So 490.5 times cosine 30 is negative 424.8. Force normal in the horizontal will be equals to 0. On the vertical will be positive, F and 2. Tension will be in the horizontal negative tension, because it is on the opposite direction of the positive horizontal. And on the vertical is equal to 0. And when we are done with all the forces, we are at force net. In the horizontal, what do we have is the object moving down the incline. So is on the same direction as the positive horizontal times A. And on the vertical is not moving in the relation to the vertical axis. So here we have all three equations from vertical of the first object, horizontal of the second, vertical of the second. Then we'll have negative 147.15 plus t is equal to positive 15.0 times acceleration. And then we will have 245.25 minus t is equal to 50 times acceleration. And from the vertical, we can still write right away that force normal is 424.8 newtons. So now, using equation 1 and equation 2, just adding the two together because they are with the opposite signs now, the tensions. So adding the two together, negative 147.15 plus 245.25 will be adding, so 1 plus 2 will give us 98.1. T is cancelled, is equal to 15 plus 50 is equal to 65 times acceleration, dividing both sides by 65. Then acceleration will be 98.1 divided by 65, 1.51 meters per second squared. And then you take this value and substitute it in any of them. I will substitute it on the first equation. So on the first equation, negative 147.15 plus t is equal to 15 times 1.51. And then from here, we find that t is 15.0 times 1.51 plus 147.15. And tension is 169.8 newtons. Do you have those values in your work? So let's start with building the free body diagram for both objects. Object 1 will be very similar to what we did before. Force of gravity 1 and tension. And the object is going up. And for object 2, what we have is force of gravity 2. And since we are dealing with a incline, force normal will be perpendicular to the object to the surface, sorry. And then we have a tension that is along the string, starting from the object. And since the object is going down the incline, then force of friction will be against the motion. So if you extend the vertical axis, the angle created with the vertical axis and the force of gravity is the same as the angle of the incline, creating this as the vertical component of the new axis and this as the horizontal component of the new axis. Because the new axis will be horizontal along the surface in the direction of the motion and vertical perpendicular to the surface. Then we start building the table of components for both of them. So for object 1 is easy because the horizontal is all zeros. So we'll have force of gravity 1, tension, and force net. 0, 0, 0 for the horizontal, and for the vertical we'll have negative 15 times 9.81 is 147.15. I should remember this. Positive t. Now the object is moving up, so it's moving on the same direction as the positive vertical axis. For object 2, the table of components will look something like this. We have the new horizontal axis and the new vertical axis, starting with force of gravity, and then moving to force normal, tension, force of friction, and since we are done with the forces, then we write force net. So the horizontal component of force of gravity will be 50 times 9.81, which is the force of gravity, 490.5 times sine 30. And it is on the same direction as the positive horizontal, new horizontal axis, so positive 245.25, and the vertical is negative, so, and it is related to the adjacent, so will be cosine, and it's negative 424.8, let's say, if we round it. The horizontal for the new horizontal for force normal will be 0. Vertical will be positive force normal. Tension will be negative tension on the horizontal and 0 on the vertical. Force of friction will be negative force of friction, and on the vertical is 0. The object is moving in the same direction as the new horizontal, so will be positive 50 times acceleration, and for the vertical is 0. So then what we have is we have 3 equations that we are creating using the table. Negative 147.15 plus t is equal to 15 times acceleration. And then from the horizontal of the second object, we'll have 200 positive 245.25 minus t minus force of friction 2 is equal to 50 times acceleration. And from the vertical, what we have is force normal will be equals to 424.8 newtons. Since we know force normal, we can even find force of friction, because as coefficient of the friction times force normal. So coefficient of the friction is 0.8 times 424.8. So therefore, the force of friction will be 424.8 times 0.08. It's 33.98 newtons. Then equation 1 and equation 2 is now as negative 147.15 plus t equals to 15 times A, and 245.25 minus 33.98, that is the force of friction, will be 211.27 minus t equals to 50 times acceleration. Now what we do is we add the two together, and by adding those two, the tension is cancelled. So 211.27 minus 147.15 is 64.12 equals to 65 times acceleration. Divide both sides by 65. Then acceleration will be, so 65, no, divide by 65. Acceleration will be 0.986 meters per second squared. Take this value of the acceleration and substitute it on any of the equations, 1 or 2. I will take equation 1. So negative 147.15 plus t is equal to 15 times 0.986. And from here we find t is 15.0 times 0.986 plus 147.15. So 15 times 0.986 plus 147.15. Tension will be 161.94 newtons. And this is how you solve those kind of